Hello guys, we're back again today. I want to discuss something very interesting. We want to discuss something in analytical geometry, where we represent lines, equations, shapes, objects, and everything with the use of equations. This is quite interesting. Like today, we want to talk about the equation of a straight line. Equation of a straight line. Have you thought about it? Actually dealing with the straight line, talking about the straight line and actually applying it without even drawing the straight line itself. That is analytical geometry. And that's what we want to discuss. And I want to show you about the equation and how to derive the equation given points, what we call coordinates. So if I have a straight line of this nature, I can have a coordinate to represent this. I have a coordinate to also represent this. The coordinate has to do with the x and y unit measurement from the origin. So I'm going to be talking about the straight line, and I'm going to be talking about and dealing with a plane. So if we have this as a plane, and this is the y-axis, this is the x-axis, and here we have the origin, no measurement, origin. If I have this, that's simply a straight line. This is a straight line, but it's actually passing through this point, which I can call C. So generally, we can represent this with y equals to mx plus c, where the m there actually represents the slope. The slope here, or the gradient at this particular point that corresponds to this axis. So that is the slope, which is m. X and y are arbitrary values, and c is the intercept at the y-axis. This form, y equals to mx plus c, is what we call the slope intercept form. The slope intercept form of the equation of a straight line. One of the advantages of the slope intercept form is that you can actually visualize the slope and the intercept c and the slope very easy. So that's why it is called the slope intercept form. But we have a general form. And the general form is quite interesting, and that is ax plus by plus c equals to 0. But note, some textbook can use PQR, some textbook can use STU, and so on and so forth. But the most important thing is that this is a constant, this is a constant, and this is a constant. So this is a general form of the equation of a straight line. So for instance, if I have something like 5x plus 2y minus 1 equals to 0, this actually represents a straight line. One of the reasons, and one simple thing, is that this is a linear equation. The highest degree of this equation is just 1. And so that's why we call this a straight line. So it's always going to represent a straight line. And if I want to I'll sketch the straight line, I put x as 0 into this. I'm going to have this to give me y as 1 over 2. If I substitute y as 0 into this particular equation, I'm going to have x to be 1 over 5. So I can find this value, y, as half on the graph, and also find this value, x, as 1 over 5 on the graph, and sketch a particular graph that represents this. So I can do this, locate half, let's say somewhere here, this is y-axis, this is the x-axis, the origin. So I can actually locate y as half here, let's call this half, and x as 1 over 5, probably somewhere here, and I can actually draw a straight line passing through those points. But that's not really what we want to discuss today. What I want to discuss is how can we solve all this without having to draw all this? How can we solve all this without having to draw all this? And how do we do that? For you to obtain equation of a straight line, you must find the slope m, which is y2 minus y1 divided by x2 minus x1. And once you have done this, you apply the formula y minus y1 equals to m into x minus x1. So you can use this equation anytime to obtain a straight line at any point when you are given x1, y1 and x2, y2, which are distinct points on the plane. So once you have these two distinct points on the plane, you can actually get this equation of a straight line. So I would like us to do a little example. I think that would be of good use. So let us see how we can have a fast example. Permit me to use this part of the board. Okay, so let us find the equation of a straight line passing through the point 1, minus 3, and 4, and 6. So this is a point A, and this is a point B. So visualize this. So you visualize this. It's a straight line, but we actually want to find the equation that represents this. How do we do that? This is my x1, and this is my y1. This is my x2, and this is my y2. So knowing this point, I'm going to apply it in this formula. And if I apply it in this formula, I'm going to be having 6, which is y2, minus y1. So that will be minus 3. Take note that there is a minus value here, and that is why I have this. Divided by x2, which is 4 here, minus x1, which is 1 here. So that we have 4 minus 1. And solving this is going to give us 9 over 3, which is simply 3. So my slope is 3. So how do I get my equation of a straight line? I get my equation of a straight line by using this equation. And that is going to give me y minus, what is my y1? It is minus 3 equals to the slope. Oh, where are you? The slope. This is the slope. It is the slope. And that will be 3 into x minus x1. And that x, and x1, where are you? x1 is 1. So what I need to do is to simplify this and write it in this form or in this form, any form I want. Already I know the slope. So this is going to be y plus 3 equals to 3x minus 3. Solving this, I'm going to be having 3x minus y minus 6 equals to 0. So if I collect like terms here and I arrange this, I'm going to land at that equation. And this is the equation of a straight line which we can't even see. Analytical geometry, I'm going to be back talking about perpendicular lines, angle between two lines, slopes, relationship between slopes. I'm going to make a full video of that and also talk about the circle, hyperbolas, and conic sections, and so on and so forth. Thank you for listening. Have a nice day. Bye.